All right, so now we're going to talk about an important topic, which is that of interpolation. And if you recall, when we first discussed numerical methods at the start of this course, one of the things I said was that a very, very common method of constructing numerical methods is to take a problem, approximate it in some way, and then try to solve that approximate problem exactly. Okay, and interpolation is one of those tools which helps you in the process of constructing this approximation. Okay, so it is of theoretical importance in sort of a variety of applications. So, for example, we'll see how interpolation leads to a class of methods for numerical differentiation, methods for numerical integration, and solutions of differential equations. Amongst others, right? So this is not the only, it's like sort of application of interpolation. And again, it's like many, it's like numerical algorithms can be interpreted as taking a problem, approximating it using, for example, interpolation, and then solving that resulting approximate problem exactly. Okay, so as in terms of practical importance, some of it has to do with the fact that, again, many numerical methods give you a sampling, if you will. It's like of the solution at a bunch of points, perhaps on some sort of regular grid. Okay, so the circles here correspond to known values, for example. And so either maybe because you've only sampled the data, it's like at these points, or your numerical method only gives you the solutions at those points, but you happen to want to know, say, the solution away from those points, then you want some way to take this data and use that to give you an approximation of the value, say, away from the known data points. Okay, so that's another application of interpolation. So let me try to state the problem a little bit more precisely. Okay, so if you're given a function, for example, let's say f of x, or a set of discrete values, okay, so what I mean is I give you xi and the function value at that point, fi. Right, I want to find a function. Let's call that g of x, right, which in some sense approximates f of x. Okay. All right. So that's sort of the problem. Let me talk about two possible approaches to this. Okay. So the first one is what I call approximation. Okay. So so what that is that you find a function which minimizes some error measure. So you want maybe that the error between f and g measured in some sort of functional norm to be small enough, say less than epsilon. All right. So as an example of something like that, right? If you recall, we did this thing having to do with regression. All right. So that set of data might be just these data points, and you're trying to find some best fit to that data, which I'm going to call g of x, right? So an example of this is regression. Linear regression, it's like the example we saw before. And so this idea of approximation makes some sense when you believe that there is some error in the data. So you don't necessarily want the function which you construct to go through all the points, all right? So you allow for the possibility that there's some sort of error. And an example of this is sort of linear regression using least squares, right? So that's something which we discussed. Another approach is what I call interpolation. And the idea behind interpolation is that if you have the data, you want the function to go through every single one of those data points. So you want to fit the data. Okay, so you choose g such that g of xi is equal to f of xi in the continuous case, or g of xi is equal to f sub I in the discrete case. Okay, so as an example, right, if you have sampled the data like so, you want to actually choose a function which goes through all the data points. Okay, and as you might expect, since you're choosing a function which actually goes through all the data points, that only really makes sense if you actually believe the data to be true, right? So if you believe the data. Okay, so approximation makes a little bit more sense. It's like if you expect that there's some error in the data, so you don't necessarily want to prioritize going through every single data point, right? But if you absolutely believe in the veracity of your data, then you want it's like the function to go through all the data points, right? So approximation versus interpolation. Okay. All right. So let me just stop here for now.